Using structural formulas, write down a balanced equation for reaction 1. Let's go ahead and take a look at reaction 1. We are starting with but1 in. We are adding a hydrogen and a halogen to get some product X. Well, in our previous videos, I've made it very clear. If a reaction starts with an alkene, it is an addition reaction. Without looking at any other thing, if it starts with an alkene, it is an addition reaction. No questions asked. What are we adding in this reaction? We're adding a hydrogen and a halogen. Well, let's start and see what we're going to have. We are starting with but1 in. So that is 1, 2, 3, 4. And on the first carbon, we have a double bond. So now it's just a matter of filling out the hydrogens. Let's go ahead and do that and see where we end up. Right, there we go. We have but1 in. Let's make sure that we have the correct number of hydrogens. On this carbon, we have 1, 2, 3, 4 bonds. So that is okay. On the second carbon, we have 1, 2, 3, 4. So it seems like everything checks out. So what are we adding? We add in a hydrogen and a halogen. The name of this addition reaction would be hydrohalogenation. The name of an addition reaction comes from what you are adding. Well, let's go ahead and have our products. It is easy to see that this double bond is going to break to accommodate the hydrogen and the halogen. But where is the hydrogen going to go? Where is the halogen going to go? The hydrogen is going to go to the carbon with the most number of hydrogens already. If you look at our situation, this first carbon here has 2 hydrogens and the second one has 1 hydrogen. So the hydrogen is going to go to the carbon with the most number of hydrogens. That is Markovnikov's law. So let's go ahead and have our product now. We're saying that our hydrogen is going to go to the first carbon as it has the highest number of carbons compared to the other carbon that it can possibly occupy. Yeah, so from this reaction, this is our major product. Our minor product is when the halogen is on the first carbon. That is 4.1, 4 marks. Let's go ahead and do 4.2. Write down the name of the type of reaction that occurs when but1 in is converted to compound X. We already know that if a reaction starts with an alkene, we have an addition reaction. Quite an easy question to answer. 4.3. Write the structural formula and IUPAC name of the secondary alcohol Y that forms. So we've but1 in, and through some reaction 3, our product is a secondary alcohol. Well, it is starting with an alkene, so we know that it is an addition reaction. Which addition reaction leads to an alcohol hydration, right? So given that it is a secondary alcohol, but we would also be able to get to a conclusion that the alcohol that is formed is secondary. But anyway, let's go ahead and have our alcohol. 1, 2, 3, 4. On the second carbon, we have OH. Yeah, that is wrong. It's not supposed to be like that. We're supposed to have a dash here to show that OH is not one thing. It is an oxygen bonded to a hydrogen. If you are writing the structural formula, you need to put that bond there. Well, everywhere else we have hydrogens. So we can just go ahead and put that there. Again, our product is a secondary alcohol because of the Markovnikov's law. Let's go ahead and name this alcohol. How many carbons? 1, 2, 3, 4. Which side are we numbering from? From the right, because our OH is going to be on the second carbon. But if we start numbering from the left, it is going to be on the third carbon. Well, it means that our IUPAC name will be butane all, right? The functional group is on the second carbon. That is 4.3. Let's do 4.4. Name the type of substitution reaction that occurs when compound X is converted to the secondary alcohol Y. So there is only one substitution reaction that can give you an alcohol. It is hydrolysis. There is no other substitution reaction that leads to the formation of an alcohol. So without thinking very hard, we know that the answer is hydrolysis there. If your alcohol is formed through a substitution reaction, it is hydrolysis. If it is formed through an addition reaction, it is hydration. Yes. 4.5, 4.5.1. Butane can be converted directly to the secondary alcohol without the formation of the intermediate product X with the help of a catalyst. 4.5.1. Except butane, write the name of the reactant needed for this reaction. Well, a reaction that takes us from butane to the secondary alcohol, it is an addition reaction. But they don't want to say now in 4.5.1 because it is a equation in 4.2. So if they tell you what it is, then you can actually say, oh, okay, it means that the answer to 4.2 is addition. What do you need to add to butane in order to have an alcohol as your product? You need to add H2O, but they say the name. So if you write H2O, it is wrong because H2O is not the name. The name is water, right? That is another trick to the question, because if you write H2O, I'm telling you, your answer is wrong. You need to write water. And 4.52, write down 4.5.2, write down the formula of the catalyst that can be used. If you write sulfuric acid, your answer is wrong. The question says formula. So you're supposed to write H2SO4 and 4.5.3. Name the type of reaction that will occur during this direct conversion. It's 2 marks for one question because the same question is getting asked in 4.2. The type of reaction that will occur is addition.